So we've been working with linear equations, and we've been working with linear equations numerically and also getting them onto the graph or graphing linear equations, drawing pictures of them. And something that you may have noticed is that they look different on the graph. So a key thing about linear equations or lines is that they have a particular slope. The slope could be thought of as the rate of change or a measure of how steep the pitch is. Sometimes we talk about the slope or the pitch of a roof or the rate of increase or decrease. So we could have a positive slope. Hopefully that's what your bank account is doing over time. You could have a negative slope. And hopefully that's what debt is doing over time. We could have this case of a zero slope or no slope. So in that case, slope equals 0. And we know that 0 and undefined are very different things. We talked about that when you were dividing by 0 or 0 divided by a number. Undefined slope is an up and down line. And so on your calculator, if you were to calculate that or measure it, it would say error. But in math, we talk about how the slope would be undefined. Now we know that this is a horizontal line. And when we were dealing with horizontal lines, we said that they're kind of that odd case where y equals a number, and then it just stays like that. So for this case, if I go with a hypothetical, that line, that equation of the line might be that y equals 2. For the undefined, that is a vertical line. And the general equation for that was that x equals a number, and maybe I could make this one just a little different. Maybe this as a hypothetical or as an example is an x equals a number, or in this particular case, an x equals 3. So just as a reminder always of these oddballs, the horizontal and the vertical lines, it might be worth making a few notes. I think you'll find on your formula sheets this exact little thing, right? Just to remind yourself of what these general slopes are. So if it is a numerical measure of the steepness or the rate of change, we can calculate slope. And so slope, as we talk about it, is the rise over the run. So you may have dealt with construction, and maybe you're familiar with a 512 roof pitch, right? Where it'd be 12 feet by 5 feet, and the measure of this steepness, this angle, would be your slope. So we talk about it as the rise, or we could talk about that as the vertical change, or we know that our vertical axis is y, right? So it's the change in y over the change in x, and that's the horizontal change. It's also called the run or the change in x. So pick one of these. I tend to like this one because it's the mathiest of them all, but probably some of those other ones have something in them that you can relate to from your world already. And so I like this one where the slope is the change in the y value and the run is the change in the x value. So this gives me an equation that I can take and plug in two xy ordered pairs, right? So if I do this, I have these 2 points on the graph. And if you wanted to, like if you're really a picture person, you could graph them. But numerically, we can calculate the slope here if we know that this is x1 and this is y1. That 1 down below doesn't mean anything other than this is 0.1. And then this is x2 and y2. And again, those are not exponents. They're really just saying that this is 0.1 and this is 0.2. And so subbing into my slope equation, slope would equal y2 minus y1, and that is the change in y, and x2 minus x1, and that is the change in x. So I go ahead and label these because I'm really good at picking and choosing the wrong numbers. And so then I'm just going to sub into my equation. So because I've already labeled them up, I simply take a look at what I've labeled. So my y2 was 5, and my y1 was 3. In these ones, you can absolutely sub in with brackets. In all honesty, I drop it. I only sub in with brackets when it's a negative number. So go ahead and sub in with brackets if you still find you're making errors on that. But sometimes, in all honesty, not putting the brackets in, especially when there's no exponents, can actually make things look a little bit easier for you. Okay, so that's my y2 and y1, and then I'm going to do x2 and x1. So that's a 5 minus 2. So if I do the math here, I'd get a 2 over 3. So that tells me that I have a rise of 2, so a change of 2 points up, for a run, or a change in the horizontal, of 3. So if I were to do and draw this quick, I'd go from one point to another, I'd go up 2 and over 3, right? That would be the steepness of my line. Now this isn't on the coordinate plane. We're going to roll all this together. But at this point, we're just dealing with this key element of lines as the slope. So we're going to try some more. Take your time to label x1 and y1, because again, that's point 1, and x2 and y2, because again, this is the second point that I care about on this line. So now the slope equation, I'm going to skip copying out again. I did on my key. It's right up here. This is what I'm subbing into. So slope would equal y2, which in this case is 6, minus a negative 2. So like I said, when it's a negative, I do use the brackets, because you can see here, that's really going to change your arithmetic, right? It's really going to change your answer. So then I'd have a 3 for my x2 minus a minus 1. I can make this look a little bit simpler. Negative negative is a plus, or you can put that in your calculator if you type it in exactly like you see it. On the top, I would end up with an 8, and on the bottom, I would end up with a 4. So slope is a key place where fractions are absolutely your friends. But in order to get the simplest answer, always fractions need to be reduced. So this one I can reduce, I can divide both by 4 and get 2 over 1. So then I can see it's a rise of 2 and a run, or a change of x, of 1. Or I could just write that my slope is 2, right? By seeing it with the rise over the run, that's a little bit more practical, but really bringing it down to its easiest answer, simplest answer, it would just give me a slope of 2. Okay, let's do another one here. I take the time to label them because I'm really good at copying wrong and making simple mistakes. So my slope would be negative 3, and you could sub in with brackets. I'm showing you how I do it, which is a little lazy, minus 3. Then I would have 1 minus minus 1. And so there you can see I subbed in with brackets. If it makes it you happier to put brackets around that negative 3, for sure you can. On the top, we'd have negative 3 minus 3. Use your calculator. Don't do what's easy. Do what it actually says. We get negative 6 over 1 minus minus 1, which is 1 plus 1, or 2. And again here, you can see that we don't have it in lowest terms. I could change this to a negative 3 as my slope. And really what that means is that it's a negative 3 over 1. So this is the case of a negative slope from at the top. So that means that we're going to rise, or go down, 3 for a run of 1. And if I take a look at that, from one point to another, this is telling me go down 3 and over 1. I would have a pretty steep negative slope on that line. So again, what you calculate and what it actually means are a little different. So hopefully we can kind of, go between those two as you learn this equation. Okay, so D and E, still staying with the slope equation, they have stars beside them because there's something funky about them. So I'd have an x1 and a y1, and an x2 and a y2. You may be able to see through this one to the answer. Certainly if you put these two ordered pairs on a graph, you would see that. Um, if I take and sub into my slope equation, what I get is y2, so -4 minus -4. Oh my goodness, negative numbers. And then x2 is a 3 minus my x1, which is -2. Making some sense of that, what I have on the top here is -4 plus 4. And on the bottom, I have 3 plus 2. You could take that intermediary step, or you could just plug it into your calculator. On the top, you're going to have 0 divided by 1. In your calculator, you might remember this from my explanation before. This is on. If you put this into your calculator, it's going to tell you that you have a slope of 0. Now, a slope of 0 was that funny case of being a horizontal line. Let's just prove it to ourselves. So this is my coordinate plane in kind of a sketchy sense. And I'm going to graph these two ordered pairs. So this tells me to go to -2 on the x and -4 on the y. The other one, the ordered pair, is 3 on the x and -4, oh, look at that, on the y. You can see that graphing those ordered pairs gives me a horizontal line. We can see that in here, I'll just change colors because I got a lot going on. You can see in here that we've got a -4 and a -4. If I were to give the equation of this line, and that's way overstepping this question, it would be that y equals a -4. You can guess what this one's going to be. Go ahead, guess. You may be able to see through the answer and you might not. Let's just keep walking through this as a skill. So this is x1 and y1. This would be x2 and y2. And again, don't mix and match your little subscripts down here. That 1 tells me that this is 0.1. The 2 tells me that this is 0.2. So subbing into my slope equation, I would have 5 minus -5 and 2 minus 2. Do the math carefully, I'd have 10 over 0. Remembering what this is, or you can punch it into your calculator if you're not remembering. This tells you no, you can't do it. Your calculator is going to tell you error. In our world, that means that this value is undefined. If you look back to the top of the page, that tells you this is going to be a vertical line. But let's just test it out to see how this makes sense. So graphing ordered pairs, we really just find on the number lines that coordinate location, right? That'd be -5 down here. Is that right? 1, 2, 3, 4, 5. Yeah. And then 2 and 5. So I'd go to 2 and a +5. Oops, 1, 2. And sure enough, if I connect those two dots, my line's going to be wacky because drawing vertical lines is tough for me. It is a vertical line. It would be, if I were to really take this way too far, that would be that x equals 2. In here you can see that the 2 isn't changing, right? X is always going to equal 2, and y could really be anything here. And so these are kind of those oddball cases. It's actually a little bit nicer when you get something that is 2 over 3, right? Whole numbers are weird. Negative numbers tell you to go down. And I do want to make a distinction. So ordered pairs give you a location. So x, y equals a spot on the graph. And slope tells you direction. So it tells you how to go from one point to another. So that tells you how to go one point to another. Whoops, I ran out of space. So just sometimes people get a little bit confused because there are X's and Y's all over the place. They're two separate concepts and they're not individually hard, but sometimes people get them muddled. So this is your word of warning. Don't get those muddled. So these ones, I decided to give you those graphs to draw on because they're a little bit neater than what I was doing back there. So if we graph point 1 and we graph point 2, this question says, what is the slope? And so it is possible if you want to calculate it, you absolutely can. But let's try it this way. So we're going to go to -3 and 2 on the graph, and we're going to go to 2 and 5 on the graph. So if I were to draw that, oh, almost hit it, as a line, actually that's pretty good. I'm impressed. And then I want to figure out what the rise is over the run. So I can count, how many do I have to go up or down? So 1, 2, 3 up. And how many do I have to go across? So it's 1, 2, 3, 4, 5 spaces across. So my slope is 3 over 5. If you want, you could calculate it, right? You can calculate it, or you can count, right? Knowing that it's instructions to go from one point to another. And again, this is the 3 up, and this is the 5 across. So we got another one. I was just trying to be economical with my paper and my graphs. So we can do this on the same graph here. Again, we have a point 1 and a point 2. If you want to practice calculating this, it should work out the same both ways. But graphing this one instead, I'd have 4 and -3 as my point 1. And then this point 2 tells me to go to -3 and 5. Oh, that's a little awkward because that was already part of my other graph there. If I was to connect these, I can see it like that. I can see that it's a negative slope. If you think back to those initial pictures, going from one point to another, I could count it out. I'm going to have to go down from this point to the other. So 1, 2, 3, 4, 5, 6, 7, 8. So I went down 8, right? I'm looking at my slope. It's down 8 and it's over 1, 2, 3, 4, 5, 6, 7. So -7 over 8 is my slope of the line that has these 2 points on it. There is a curious thing, and maybe I'll do this one time. I do always say that the negative goes with the denominator or the numerator because that's easier in my head. I'm much happier knowing that the negative tells me to go down, right? You could put the negative with the 7. So I could say it's 8 over -7. So this is telling me from one point to another to go up 8 and left. And so I get a little bit bongled on my left and right sometimes, but this should work. So to go from this point to another, I could go up 8 and left 7. So I like this way better. I like putting the numerator or the negative with the numerator because I find that I'm a little bit better on up being positive and down being negative. But this was just an illustration in yellow here to say it kind of works both ways. So trying the last ones, and we did a little bit extra work on the other page. So you could calculate with these 2 points, or we can put them on the graph. So we got -2 and 3, and we've got 5 and 3. The slope of that is 0. That's a horizontal line. If you were to calculate it, it's going to be 0 over a number. It's on, right? And that's a horizontal slope. The other one, and again, if you want to practice using your slope equation, my answer key actually shows all that work. I'm going to speed it up a little bit here in the video. So we go at 1 and -3 and 1 and 4. And oh yeah, not very good on the vertical lines. Pretend that's a straight line and I'm a much neater person. My slope here is not 0. This is undefined. Weird case. I don't know of anybody's bank account that has that rate of change in it. It'd be kind of nice, I guess, but not really possible. Okay, so given the graph, find the slope. So again, just dealing with the same thing, you can absolutely take a look at these points. I'll write them just a little bit bigger because I know what they say. They're hard to read on your paper. You can do this one of two ways, right? You can sub in to the equation for slope, or you could just count it out, right? Look at the rise and look at the run. And you always put the rise over the run. Okay, so in here, we could go a rise of 1, 2, 3, 4 over 3. So I have a slope of 4 over 3. Improper fractions, always better than mixed numbers. And this is about the only case that fractions are really, really useful because they spell out the rate of change on an XY coordinate plane. Okay, so the next one, I'm just going to count it out. You could graph it. I can see from one point to another, my instructions would be to go up 1, 2, 3, and over 1. So you could say 3 over 1, or you could say that the slope is really just 3. And again, we're calculating slope down here, or determining slope. And the last one, if I look at it overall, I can see it's a negative slope. But if I go from one point to another, I'm going down 1 and over 3. So a negative 1/3 as my slope. If you take a look, you can also go to multiple points. So all the points on the graph that work out nice and neat have those same instructions. So here I'm going down 1 and over 3 to get to the next. Down 1, over 3, down 1, over 3. It's a consistent rate of change for a straight line. And do keep in mind, the overall positive, negative slopes. You know the pictures of those. So keep those in mind. All right, so we've got a few more things. We're going to keep this a little bit mathematical here. This is going back to stuff we did. So the table method, if we have the equation of a line, we want to put that on the graph. So we've just been graphing ordered pairs, but now we're going to determine our ordered pairs with our table method. With table method, you can always choose the numbers. I don't see any fractions in my equation, so I can pick any numbers I want. Technically, you only really need two points, but I'll go the third just to make sure I don't make a mistake. So I'd have y equaling -2 times 0, or y equaling 0. So that is an ordered pair. That is one of the points on my line. The next one, I choose these ones, right? Remember, you choose your x and then you solve for the y's. So I'd have y equaling -2 times 1, y equals a -2. So this gives me another ordered pair. So I go to 1 and -2. I could just draw a line between those two. I'm doing a third point just as backup here. So I'd have y equaling -2 times 2, or y equaling a -4 when x is 2. So I can fill it in my chart and I can make that third ordered pair on my line. So I can draw it like that. The whole point of this is take a look at the slope. So the slope is the rate of change. And if we see here, it's down 2 and over 1. I'm getting ahead of myself, but look at that -2 right there. See a -2 over 1? That's your slope, right? It says it right in the equation here. Okay, let's take a look at another one. I'll come back to that, and definitely coming back to that in the next section. So this one says we've got y equaling 1/3 x. I see that fraction, so that tells me I'm going to pick multiples of 3 unless I want to graph fractions, and I'm pretty sure none of us want to. So I've chosen those numbers because I had that fraction there. And now I'm going to solve for y. So y equals 1/3 times 0. That's always an easy one. Sub it in those zeros. So 0, 0 is a point on my line. The next one would be y equaling 1/3 times 3. Those cancel. I've got that y equals 1. Some fast fraction math there. Hope I didn't lose anybody. There's another point, and technically that would be enough to draw my line, but let's just do the third one for practice. And because sometimes I make mistakes, I get y equaling 6 divided by 3, or I could think of it as over 1, or I could cancel. In any case, you get a 2. And again, this is my third ordered pair to draw my line on the graph. Remember how I said that coefficient in front of my x was my slope? Check this out. This is an up 1 and an over 3, right? My slope is up 1 and over 3. Look at that coefficient. That is my slope. So we're kind of rolling these all in together. We're going to come back to slope in our equations. But slope is also, like I said, it's a rate of change. It's slope. In other mathy words, and I don't think that you've probably thought of these ones before, it's a constant of variation or a proportionality constant. Big fancy words, but they're all the same concept. This is the format of the equation, right? If you take a look at those two examples you just graphed, they were like that. In real world applications, if you make $9 an hour as a tutor, right, that's your rate of pay, right? Remember I said this is your rate of change or your slope. Write the equation that describes the relationship. Well, if you get paid, I'm going to say P is payment and H is the number of hours worked. You know how to do this. Your pay would equal 9 times the number of hours worked, right? You could graph that, how much your paycheck is going to be worth. If you work 0 hours, you're going to get 0 paycheck. If you work 1 hour, you're going to get $9, right? That would be the rate of change. 2 hours, we get $18. Right? You can do this calculation. You know what you make for an 8-hour shift. And this is just an application of this proportionality constant or constant of variation, really making things complicated. So if you drive at 50 kilometers an hour, and you drive for an hour, you're going to have gone 50 kilometers. Again, leveraging stuff you know and trying to make some, I guess, maybe contrived connections to math. So in this one, distance is going to be d. I'm just making these ones up. Oh, it says little d there. And then h is hours. The distance you travel is always equal to the rate you travel at, so 50 times the number of hours that you travel, right? Distance equals rate times time. That's always like a constant thing, and it's something that you know, but here's an example. This is your rate of travel, right? And your total distance is going to be that times however many hours you travel. Okay, so making this applied again, but using all those mathy words. This one says, find the proportionality constant or the rate of change. So again, that format of the equation, y is going to equal k times x. This is your proportionality constant or your rate of change. I guess it's constant starts with a K. Somebody told me that constant starts with a K in German. I don't know if that's true. So in this one, we don't know what this one is. We don't know what k is. So that's what we're supposed to be finding. But we do know what x equals. That equals 6. And we do know that y equals 30. So k is what we're looking for. It doesn't say come up with the equation. Well, it does eventually. But it does say you have to figure out what k is first. So subbing into this format of my equation here, I'd have 30 equaling k times 6. Getting k by itself, I divide both sides by 6, and I get that k equals 5. So that is my proportionality constant, right? Give the equation of the line, y would equal 5x. When we have equations of lines, we have y's and x's as placeholders, right? Those would be the ordered pairs that would be on the line. But the generalized algebraic equation just has a y and an x in it. And the key thing here is that we had to solve for that k. If you want, give the video a pause and try this one. This one says y varies directly. So that's that lingo. There's a constant of variation or direct variation. We know that y equals 100 and x equals 25. It says find that constant of variation. That's what we're looking for is k. And after we figure that out, give the equation or give the function that illustrates that. We can just go equation. Okay, so in this one, let's take a look. We've got for my format of my equation, we've got y being 100. We've got k being what we don't know, and we've got x being 25. So I subbed into my format, right, because I had this lingo in here. I divide by 25, and I'd get that k equals 4. So my equation then, taking it back, so there's a y placeholder and an x placeholder, and I know the value of my k, right? That would be the equation of my line, or the function in a fancy mathy way of saying what's going on. Another one, or last two, it says let y vary directly with x. We have a constant of variation of negative 1/3. Graph the equation, and we're going to start with a table on this one. So we know that if k is 1/3, my equation is y equals a negative 1/3. Sorry, I forgot to say negative there. X. So that's my equation. It says start with a table to find 2 points. Now you could do 3. I'm being a little bit lazy. Subbing in a 0 gives me a 0, and you can show your work on that. I love subbing in zeros, and I'm going to pick a 3 because I've got that fraction. I don't want to have to graph fraction, so y equaling a negative 1/3 times 3. Watch your signs, watch your fraction math. I get a negative 1 for what that's worth, right? So these give me 2 points that I can graph. I'd have a 3 and a negative 1. I can draw the equation of my line. And really kind of bringing it all in together, that constant of variation is your rate of change and it is your slope. A negative 1/3 tells me to go down 1 and over 3 to get to all of the points that are on the line. Or I could go up 1 and to the left 3 to get to those points on the line. The last one here, if I were to graph this, I know that my equation is going to be y equaling 2/5 x because that's my k value, and going back to that format of the equation here, I'm going to make a table. I'm going to sub in a 0 and I'm going to sub in a 5, staying out of fraction land. Take your time, sub those in. You might be able to see through the numbers quickly on that. I'm just speeding up so the video ends quicker here. It's long enough. And now I'm going to graph these two ordered pairs. That allows me to draw this equation of the line and double check this concept that that constant of variation is the slope of my line. It is the rate of change. It tells me I've got a rise of 2 and a run of 5 between all of the points on my slope or on my line.